So last time we talked about the Portage Lake volcanics, those lava flows that piled up over millions of years. After the lava flows stopped, there was a period of erosion. And in that time of erosion, this basalt, our basalt is called a Portage Lake volcanic. So that those are kind of interchangeable terms. But these Portage Lake volcanics weathered and broke down into these chunks. And then these chunks piled up on top and got cemented over millions of years, got cemented into this Copper Harbor conglomerate. Now, it's a conglomerate because it's made up of chunks of gravel. There's big chunks, little chunks, even a matrix that's finer grained in between. But you can see it looks like concrete. It's made up of a bunch of little chunks. And you'd think that you could break this apart, but it's actually cemented together pretty well. They weathered away into cobbles and sand and gravel, and that stuff washed down the hills and filled in this depression in layers. And we call those rocks now the Copper Harbor conglomerates, because they've been cemented together. And when you first look at them, they look just like a pile of gravel, but they're cemented together, and they're pretty solid. And you see those along the shoreline from exposed from about Eagle Harbor up through Copper Harbor, and that's where they get their name, Copper Harbor conglomerate. Here at Horseshoe Harbor, near the tip of the Keweenaw Peninsula, you can see a beach made of the weathered cobbles broken apart from the Copper Harbor conglomerate. And here's an exposure of that Copper Harbor conglomerate. Just like the Portage Lake volcanics that got tilted up by the Keweenaw Fault event, the Copper Harbor conglomerates follow that same pattern, dipping underneath the Lake Superior and arising again on the other side over by Isle Royale. It's pretty easy to imagine that layer continues underneath the lake and rises again in the opposite direction on Isle Royale. Off in the distance to the west, past Copper Harbor, you can see Brockway Mountain. Brockway Mountain is just another outcropping of these Copper Harbor conglomerates. So those two rocks form the west side of the Keweenaw Peninsula. But from the fault over, on the east side of the peninsula, we have another sedimentary rock. The conglomerate was made of sediment, so it's a sedimentary rock. This rock is made out of sand grains, so it's a sandstone. And that rock is the Jacobsville sandstone. And here we see the first exposed edge of it. This is at Hungarian Falls. And you can see that it was put down in layers. Imagine a shallow, sandy kind of shoreline beach environment, and it gets put down in layers. And over the years, those layers of sand get cemented together to form the Jacobsville sandstone. And this was an important rock in our area too. In fact, they cut this into pieces and sold it to make buildings out of it. It's a great building stone. Unlike most sandstones, it's pretty well cemented. It sticks together pretty well. And so they quarried it and shipped it out of Jacobsville. They named after the sandstone. The sandstone was named after it. They shipped it out around the Great Lakes. There's buildings in Chicago that are built out of rock that was quarried in Jacobsville. Our Calumet Theater is built out of Jacobsville sandstone. Here on the eastern side of the peninsula is where you'll find this Jacobsville sandstone. It comes in a range of colors from light colored to this purplish color. This is kind of the famous one because it's a rather unique color. It doesn't look earthy, I guess. But you can see they're made up of sand grains cemented together. These sand grains came from ancient mountains just off in that direction. The nubs of them, what's left behind, we call them the Huron Mountains. They are the tallest mountains in Michigan, but it's still like less than 2,000 feet. But at one time they were huge, and they weathered away over hundreds of millions of years to make the sand that settled out in this, would have been a shallow sea at the time. In fact, sometimes you can even see ripple marks in the stone. One of the things about sandstone, because it's put down layer after layer after layer, year after year, there's weakness in that direction. So this might have been 2 different years worth of deposits or something like that. But that's called a bedding plane, and it makes it fairly easy to cleave in those directions. Where it breaks randomly in this direction it'll break off into flakes. And that makes it, that's helpful for using it as a building stone because you can shape it a little bit easier. But these Jacobsville sandstones, they butt up against the Keweenaw Fault and the Portage Lake Volcanics and the conglomerates over there, and then they stretch out under the lake. They start to the north at about Bay Degree, and they continue all the way down past Baraga. Jacobsville sandstones. On the east side, younger rocks than the Portage Lake Volcanics and the Copper Harbor conglomerates.